to go?
Yes, James and I need to decide on a project on reflection in plane mirrors. We have a lot of reading up to do.
Well, try observing your own image to begin with.
What do you mean?
When you look into the mirror, is your image erect or upside down?
Erect, of course.
How about the size of your image?
Looks the same size as me. Also, at the same distance from the mirror.
Yes, that's right. You could depict these properties of images in your science project. I'll give you an example. Let's take the letter R and see how its image is formed in a plane mirror. Place the letter in front of a mirror. We can treat this as an object. We know that light from objects reflects from the mirror. Consider a point X on top of the object and a point Y at the bottom of the object. Let MN represent the surface of the mirror. From point X on the object, consider a light ray incident on the mirror at point A. According to the laws of reflection, the angle of incidence is always equal to the angle of reflection. Observe the angle of the incident ray as it reflects and travels to the eye of the observer. From the same point X on the object, another light ray is incident on the mirror at point B, and the reflected ray travels to the eye. The two reflected rays from A and B are divergent. When extended behind the mirror, these rays meet at X dash. Thus, the image of the point X on the object is formed at X dash. Consider one more point Y on the object. A light ray from Y on the object is incident on the mirror at C, and the reflected ray travels to the eye. Similarly, another ray from Y on the object is incident on the mirror at D and is reflected to travel to the eye. Like the two reflected rays from A and B, the two reflected rays from C and D are divergent too, and when extended behind the mirror, meet at Y dash. Thus, Y dash is the image of point Y on the object.
That's a lot of rays.
Yes, it takes a large number of light rays to form a reflection of an object. So, as you can see, rays from all points on an object are incident on the mirror and reflected in different directions. That is, the reflected rays are divergent.
So, how do they form an image?
All these divergent rays are extended behind the mirror to form a complete image of the object.
So, the image is formed behind the mirror?
Yes. That's why images formed by a plane mirror cannot be obtained on a screen. Now let me show you another interesting thing about images in plane mirrors. Raise your right hand.
Okay, sure.
What does the mirror show you? Which hand is raised?
Oh, I see what you mean. In the mirror, it looks like the left hand.
Now, observe the image of the letter R formed during the activity.
Same thing, the left side appears to be on the right, and the right side appears to be on the left.
That is because of the phenomenon of lateral inversion. The image of an object that you see in a plane mirror is laterally inverted.
Hey, I can see my image in the window pane too.
Yes, the laws of reflection apply to all surfaces.
But then, Why can't I see my reflection on other surfaces, like a wall, for instance?
That's because light rays incident on surfaces like a wall are parallel, but the reflected rays are not. This happens because the surface of the wall is irregular. The reflection from such irregular surfaces is called irregular or diffused reflection. The reflection from a very smooth surface, like that of a plain mirror or a plain glass, is called regular reflection. In regular reflection, a set of incident rays parallel to each other is reflected from a very smooth surface as another set of parallel rays.
Are you saying that images are not formed on irregular surfaces?
That's correct. Images are formed due to regular reflections. Therefore, you are able to see your image in the window pane and the mirror, but not on the wall.